So I'll go through this up here and stop me if we have any questions, but we'll just have a read through the skills that we need to know. It is quite a short unit, right? It's just chapter 14 and chapter 15. Chapter 14 we did in like 2 lessons, and chapter 15 we've done over successive lessons, maybe 7 or 8. So I've got a playlist organised with all the videos. I'll email that out shortly after we film this one. And you've got the review set questions that I recommend doing. Obviously not all of them. These are the ones that I've isolated that I think are pertinent for the test coming up. So if we look at chapter 14, this is where we start learning about rates of change. And within that we've got average rate of change and instantaneous rate of change. So you are required to know how to find the average rate of change from a function. So that means you've got some function, y is x squared plus 3x or something like that, and find the y values and then average rate of change over an interval. And you're also required to know it from a graph. So you're given a graph and then you can find the coordinates of some points and so forth. So that's what the first 2 check points say. Instantaneous rate of change from a tangent. So we know if we have a curve, then a tangent is an indication of the slope at that point, right? So an awareness of the difference between the slope of a tangent and so the instantaneous rate of change and average rate of change. And if you're required to find the slope of a tangent, we will draw it for you so that we don't have all kind of different answers. Find the derivative using first principles. So the long methodical process, the beautiful process where we arrive at those derivative functions, and then use the derivative function to find the instantaneous rate of change, right? Derivative function tells us the instantaneous rate of change on the function. All right, on to chapter 15. We've got the first point, simple differentiation. The second point, we've got equation of a tangent. Third point, equation of normals. All right. On to the fourth point, determine when a function is increasing and decreasing just from looking at its graph. So we should be able to do that. But then the next one says using calculus techniques. So you do need to know both. Determine the location and nature of stationary points. So that's local max and local mins. Then we've got problems involving kinematics and problems involving optimization, both using calculator techniques, but also using your calculator to support your reasoning. That's what we should be doing. So let's leap straight into it. We've got the function x squared take 3x. Now, sometimes the test and sometimes the exam, it will say y equals, sometimes it will say f of x equals. Okay? If it says f of x, you should use f of x throughout. If it says y, you should use y throughout. You won't be penalized if you don't, but just in terms of continuity with the notation. Okay, part 1 says find the average rate of change from x is 1 to x is 2. So for the average rate of change, we call that the ARAC. That's y2 take y1 on x2 take x1, right? It's the slope. Or f of 2 take f of 1 on x2 take x1. So that means we need the y values when x is 1, and we need the y values when x is 2. All right? So I'm going to put the number 1 into this equation. We would have 1 take away 3. That will be minus 2. And here we will put the number 2 into this equation where we would have 4 take away 6. One take 3. Cool. That's all good. All right, and so then for the slope, the average rate of change, it is y2 take y1. So we're going to have minus 2. All right, minus 2. Take away minus 2 on top of 2 take 1. All right. 1.5. Yep, that's correct. So just pointing this out again. that y value, take away that y value, divided by that x value, take away that one. Okay, when we process this, minus 2 take away minus 2, that's going to be 0. And so the slope is 0 at this point. The average rate of change is 0. It's not increasing and it's not decreasing over this interval. We won't sketch the graph, but yeah, that's what it's worked out to be in this circumstance. Okay, so that's part A. On to part B. Find f dash of x. Alright, so all we're doing is differentiating this function, right? So f dash of x then will be 2x take away 3. Part C. Find f dash of 2 and f dash of minus 2. F dash of 2 and f of 2. So f dash of 2, that's going to be the result when we put the number 2 into the derivative function. We would have 2 times 2 take 3, 4 take 3, which is 1. F of 2, we've already calculated it, we did it up here. F of 2 is minus 2. Alright, that's when we put the number 2 into the original function. Now it wants us to interpret the difference between these two values. What's the difference between them? Well, f dash of x is the slope function. It tells you the slope for any value of x. We've put the x value 2 in there. So that means 1, this is the slope when x is 2. When x is 2, the slope is 1. Okay, that's what this part tells us. And then when we put the number 2 into the original function, we get minus 2. All right, this is the y value. All right, we've got when x is 2, the y value. This tells you the y value of the original function. All right, remember we use y and f of x to mean the same thing. So if we've got f of 2 is minus 2, that's the y value. When x is 2, the slope is 1, and the y value is minus 2. Okay. And then in part D and E, I'm just introducing you to, well, reintroducing you, redoing some different forms of notation. Find the instantaneous rate of change when x is 1. Okay? That means the slope when x is 1. Well, this is the slope function, so all we would do is put the number 1 into the slope function. So f dash of 1, 2 times 1, 2, take away 3. 2 take 3, minus 1. All right. And that means the same thing as E. Find the slope of the tangent to f of x at x is 4. That means find how steep it is. Find the rate of change for the function when x is 4. Okay, well that just means we put the number 4 into the derivative function. Alright, so just beware different ways of asking the same thing. Instantaneous rate of change, slope of the tangent, they mean the same thing. The difference between f of 2 and f dash of 2. This will pop up, okay? This skill will pop up. Right, Sam, just take this out for the time being. All right, question 2, on to our first principles. So, any questions so far? All right, so the formula for first principles is f dash of x equals the limit as h approaches 0 of f of x plus h, take f of x on top of h. That's the formula. Now, we're given the function x squared plus 5x take 2. Okay, so let's get straight into it. F dash of x equals the limit as h approaches 0. Okay, the first part is f of x plus h. That's where we take x plus h and we put it everywhere there's an x. So we'll have x plus h squared plus 5 lots of x plus h, and then take away 2. So this whole component, I'll put it in blue. That's f of x plus h. That's the first part of the formula. Okay, just taking x plus h, putting it everywhere there's an x. And then we have take away f of x. So just take away the function. Now you must make sure you put this in brackets because the negative will distribute to all of those terms. All right, and f of x plus h, take f of x all on top of h. Now, if you get into this formula, okay, I would say the tricky part's done, like the substitution. People sort of stumble over that part. But now we're just expand, collect, cancel h, and apply the limit. So let's go into that. Now to expand, we need perfect square rule here. And remember, we write the limit in every step right up until we apply the limit. So perfect square here, x squared plus 2xh plus h squared. And then the 5x and the 5h, and then the minus 2 just hanging out there. And then this negative distributes as well, right? Negative x squared, take 5x plus 2, all on top of h. Now, this is like the checkpoint where you get to determine whether you're on the right process or not, whether you're on the right track. So what we'll do next is cancel like terms. So the steps are what? Put it in the formula, expand, collect, cancel like terms. We've got x squared and minus x squared, cancels. We've got 5x and minus 5x, cancels. We've got minus 2 and positive 2, cancels. And so this is the checkpoint, right? Is that everything that's left over has a h in it. 2x plus h squared plus 5h. Everything's got a h in it, so that means we're on the right track because now we can cancel the h. So we'll factorize the h. And cancel it. Apply the limit. If we've got 2x plus h plus 5, h is approaching 0, we're left with 2x plus 5. And we know that's going to be the answer because we can differentiate this using simple differentiation. So you're going to know whether you're right or wrong with the answer you get, and so you should be able to get these 5 marks. Make sure we're getting these 5 marks by performing the process, right? That's going to be our final answer. Any questions about the first principles? All right, so they're nice, long, methodical, just repeating the same process. If it's a skill you need to practice, make sure you mark that one down. Okay, then on to question 3. We've got some simple differentiation. And if I'm going too fast, please stop me, guys. So I'll write these problems up here. We have f of x equals. We have y equals. And we have f of x equals. Okay. So for simple differentiation, everything must be expressed at the top of the fraction as a power of n. If that's the case, we're ready to differentiate. Here, everything's at the top and everything's at the power of n. We can differentiate here in one step. So we're going from f of x to f dash of x, okay? We're given f of x, so this is the notation we use. Now the 3 hangs out, and the derivative of x to the 4 is 4x to the 3. The derivative of 2x is 2, and the derivative of minus 7 is 0. Any number will disappear. Now you get full marks there, okay? With simple differentiation, it'll be on the first page of the test, and it says differentiate, there's no need to simplify. That being said, you won't be penalised if you express it like this, okay? Because they are the same thing, right? So you can go from there straight to there, or you can write it like this, doesn't matter, both are completely correct. Okay, on to B. Now, we've got this denominator of x, and so that means we need to split that denominator and cancel it using index laws or like terms and so forth. So we're going to express this firstly as x squared on x plus 4x on top of x. Okay, so then if we're using index laws, it's going to simplify, right? It's going to become, well, we've got x squared at the top, x at the bottom. One of the x's can cancel, and here x at the top, x at the bottom, we're just left with 4. So these are the same function, okay? We've got y equals, we've got y equals, we've got y equals. Now we're ready to differentiate it, okay? Now we differentiate. dy on dx is, derivative of x is 1. Okay, derivative of 4 is a number, that just disappears. Remember here we've got one lot of x, the derivative of kx is k, so the derivative of one lot of x is 1. Be clear with notation, y equals, y equals, y equals. These is all the same function, and then in the next step we've performed a process to it, we've differentiated, so it's now a different function. How you doing? Yeah, go for it. I didn't have anything from it.
That's right,
Yeah. Cool. Alright, on to C. Everything must be expressed as a power of n at the top of the fraction. So firstly, we've got a bit of rearranging to do. 3x to the half plus x to the minus 1. Alright, so we take it to the top, to the power of n. And we'll differentiate in one step. 3 hangs out, derivative of x to the half is half x to the minus half. Now, it's probably a good point to reiterate, whenever we have x to the minus half, okay, what this means, or half x to the minus half, it's the same as half times 1 on x to the half, which is the same as 1 on 2 root x. So whenever you see that, you can go straight to there. That's like a rule. Okay, we've been over that a number of times. That's a way that it can be simplified. That can help you find the tangent and normal and so forth. Here, you're not required to simplify it, so you get full marks there. That's absolutely fine. Full marks right there. I'm just pointing out when we've had this, it can end up here. That's what the textbook does. Now, again, clear, here's the function, here's the function, here's the derivative function. Now, one thing to be careful of, I see a number of students do this in the past, is they'll differentiate one term and then they'll differentiate another term. You can only differentiate in one step. You must differentiate everything at the same time. So an example might be they're at this step and they'll go, okay, I'll differentiate that one, and they end up with some combination of the function and its derivative. You can't do that. You have to differentiate everything in one go. So that one and that one, done. We've differentiated. Okay, so that's question 3. Any questions? All right, so that'll be on the first page. You can expect some of those. Let's go to question 4. We have the function is 2x to the 3 take 4x. All right, we're doing a tangent. We're doing a tangent at x is 1, and we're doing a normal. So for part A, for a tangent, we need 2 things. We need the point of contact and the slope. So the PLC, that means we need to go when x is 1, because we're asked to find the tangent when x is 1, what's the corresponding y value? So we have 2 take away 4, the y value is minus 2. Okay, so we need the point of contact and we need the slope. Now for the slope, we need the derivative function, right? The derivative function tells you the slope for any value of x. So f dash of x, the derivative function, all right, the 2 is just going to hang out. The derivative of x to the 3 is 3x squared. Okay, that's the derivative function. We want the slope when x is 1. So we're going to put the number 1 into the derivative function. 6 take 4, we'll get this positive 2. And so we've got the point of contact and we've got the slope. All right, now remember, both of these bits of information, you get 1 mark for that, you get 1 mark for that. Both of these pieces of information you can get straight from your graph. If you graph this function and you go trace when x is 1, it tells you the y value and it tells you the dy on dx value. We show you, you can use your calculator to check both of these, right? You get 1 mark for making just those statements. Now we're finding the equation of a line. Y equals mx plus c. A tangent is a line. This line has a slope of 2. So we've got y equals 2x plus c. So that's all good, and then we put in the point of contact. We go when x is 1, y is minus 2. Plug those in. I'll talk about what I'm doing there, solving the equation. We've got minus 2 equals 2 plus c. To get c by itself, we need to subtract 2 from both sides. So we'll take away 2 here. That means we're going to have minus 2 take 2, minus 4. C is minus 4, which means the equation of the tangent is 2x take away 4. Beautiful. Okay. Let's do the normal. So that was the tangent. Let's do the normal. So a normal has point of contact. For a normal, we need the same things. We need the point of contact and we need the negative reciprocal slope. Now this time we're talking about the x value. X is minus 2, which means the y value is going to be a little bit more complex. Alright, so I'm just putting the x value into the function. You can get this from your calculator, right? So this would be 2 times minus 8 plus 8. So what's that? Minus 8. So our point of contact, x is minus 2, y is minus 8. Alright, so we can get that from the graph. Now we saw before as well, the slope function is 6x squared take 4. We want the slope when x is minus 2. Go a bit quick. Alright, we're doing the normal at x is minus 2. 24 take 4, 20. Very steep. Okay, now that would be the slope of the tangent, right? But for a normal, we need to negative reciprocal. Okay, so we multiply it by minus 1 and flip it. At the moment, it's 20, which is the same as 20 on top of 1. So if we flip it, it becomes 1 on 20, and we make it negative, okay? So that's the slope of the tangent, therefore slope of normal minus 1 on 20. Okay, now you can do it in y-intercept form if you want to. Let's go ahead and do the general form process. If we have a slope of minus a on b, then we would write ax plus by equals c. So that's how we're going to write it in general form. That means we've got one lot of x plus 20 lots of y equals c. Plug in the point of contact. The x value is minus 2. The y value is minus 8. And just process. Alright, so in the test we've got a tangent, we've got a normal. We don't end up with pretty numbers here, alright? That's like, it's a pretty ugly one. That's okay. That's how the process is done. You just perform the algorithm. Find the point of contact. Find the slope, negative reciprocal of the slope for a normal. And then you plug it into the general formula for general form to get the solution. Okay, any questions about that? That was question 4. Very good. Let's head on to question 5. Okay. Consider the function x to the 3 take away 4x. X to the 3 take away 3x squared. Find f dash of x and draw its sign diagram. So 1 mark for f dash of x, 1 mark for its sign diagram. You can use your calculator here, can't you? So we have 3x squared take 6x. That'll be the derivative function. If we're going to draw the sign diagram of this, we needed roots. So if I'm doing it manually, I would factorize it, apply the null factor law, and there's our roots 0 and 2. And I know it's a quadratic with a positive a value, which means it's opening upwards, right? Which means it's going to have this shape. So all of that I know because I know a fair bit about quadratics and sign diagrams and so forth. But this, we can graph that, we can graph the derivative, and we can get the sign diagram from the derivative. Okay, so that's what we're getting the mark for, using the calculator to help us out. Yep, might go through some calculator skills once we're finished this, I think. Okay, so then we're asked, hence state intervals when the function is increasing. So the function f of x is increasing when f dash of x is positive, right? This is the sign diagram of f dash of x. F dash of x is the slope function. Positive slope means you're walking uphill. So we're increasing when the slope is positive, and that is when x is less than 0 and greater than 2. Decreasing within that interval. So that's part B. Part C, hence state the location and nature of any stationary points. All right, so if we're increasing and then decreasing, we're going up, then down, local max at x is 0. And when x is 0, the y value will be 0. Put 0 into the original equation. And a local min, because we're decreasing and then increasing, local min at x is 2, and the y value will be 8 take 3 times 4, 8 take 12 minus 4. Alright, now both of those, you can just g-solve those from the original graph as well. So again, a way to get them off the calculator. Alright, on to question 6. All right, so this is the optimization question. We've got a brick wall and we're building a box, a garden bed or something. Building a garden bed against the fence, and we've got that's X, and it says, show that the area is X times 40 take away 2X. Okay, so if this is X and this is X, then this length here has to be 40 take away 2X. And the reason that's the case is because the total perimeter is 40 meters. So if we have X plus 40 take 2X, we've got 40, which is how much fencing we've got. All right. So the area then is X times 40 take 2X. All right, the length times the width, which is 40X take away 2X squared. Okay, find the dimensions of the garden for maximum area using calculus techniques. Okay, maximum means turning point, means derivative equals 0. So all we're doing is finding the derivative function, a dash of x, or a dash, 40 take 4x, and we're finding when it equals 0. This is the equation of a line. It has negative slope, which means it's going from above down. Okay, so that's one way we know it's got positive, negative. The other way is we're finding a maximum, which means the original function is increasing, then decreasing. We have positive slope, then negative slope. We have a local max at x is 10. Okay, so that's the x value, all right, local max at x is 10. But we need to answer the question, what's the dimensions? Well, the dimensions are 10 by 40 take 2 times 10. 40 take 2 times 10, this length has to be 20. 10 plus 20 plus 10 gives you 40. So the dimensions, all right, you have to answer this part. Dimensions are 10 by 20 meters. Kevin?
The A dash, the 40 to the right, is it minus 40 or negative?
Nah, so what I did there, so what we've got here is 40 equals 4x, like this, like I can plus 4x on this side. Yep. Or you could have it as negative 4x equals negative 40. It's going to be the same, but all I've done is move the x on that side and then divide both sides by 4. Gives me x is 10. Now, in the sign diagram as well, notice how I've drawn this line here. That's because our solution must be positive. We're talking about the length of a garden bed, and it cannot be negative. A magnitude of length can't be negative. Thanks, Kevin. Good one. Okay, let's move on to the last question then, which is a kinematics problem. So we've got the displacement of an object is given by this equation. 3t take t squared. Part A, find the average velocity. Average velocity is just average rate of change. y2 take y1 and x2 take x1. So that means we need, what are our times? 2 and 5. So when I put the number 2 in here, we've got 6 take 4, that'll be positive 2. And when I put the number 5 in here, we'll have 15 take away 25, that'll be minus 10. 6 take 4, and then 15 take 25. Good. And so then the average velocity, y2 take y1 and x2 take x1. Average rate of change of displacement, minus 10 take 2 on top of 5 take 2. Okay, now I need to write there distance is in meters, time in seconds, which means rate of change is meters per second. Y per x, displacement is in meters, time is in seconds. So that's part A. Part B, find the instantaneous velocity. Okay, so that's average velocity, but remember, instantaneous velocity means we need the velocity function, which is the derivative of the displacement function, which would be 3 take away 2t. And we need to know what's the velocity when time is 2. So we put time is 2 into that equation. Alright. Determine when speed is increasing. This is when both acceleration and velocity have the same sign. So that means we need a sign diagram for velocity and a sign diagram for acceleration. So firstly, acceleration is the derivative of velocity. So we're differentiating this function again, and we'll get minus 2. If I look at the sign diagram for the velocity function, we have 3 take away 2t. I want to find its root. Its root is 1.5. So for velocity, there's its root, and it has negative slope, which means again it's coming from above to below. All right, we can get that sign diagram from the graph, from the calculator. Okay, so that's v of t. And then for the a of t sign diagram, well, the acceleration function is y equals minus 2. If this is your Cartesian plane, this is the line y equals minus 2. It doesn't matter what the x value is, it is always negative. And we have speed is increasing when these sign diagrams have the same sign. That is when they're both negative or they're both positive. We can see they're both negative for t is larger than 1.5. So speed is increasing for t larger than 1.5. Okay. Now, if we look at this function, very last one, we've got determine its total distance, and for that we need a motion diagram. From the velocity function, we can see that it changes direction when time is 1.5. So that means we need the displacement when time is 0. That's where it starts. We need the displacement when time is 1.5. That's where it changes direction. It changes direction because it goes from having positive velocity, moving to the right, to negative velocity. Okay, positive to negative. And then we need the displacement when time is 4, because that's when we're asked for it to finish. So we're just looking at, this is the displacement function. If I put the number 0 into the displacement function, I get 0. If I put 1.5 in, what's that, minus 2.25, and then 3 lots of it. And then if I put 4 in, so I'll do that quickly. So 4.5 take 2.25. This is 2.25. And we're going to put 4 in, we're going to have 12 take 16 minus 4. Okay, so quickly for that motion diagram then, It's an axis. It starts at here 0. It goes 2.25 to the right. Alright, so it starts here, goes to the right, and then after 4 seconds, it's at -4. So the total distance travelled then, we've got 2.25 metres here, we've got 2.25 metres here, and then we've got 4 metres here. So total distance travelled, 4 metres plus 4.5, 8.5 metres. Alright, really good. So that's a pretty thorough review, right? Everything we've touched on is everything that you can possibly be asked in the test. So I've had enough of talking.